So we're going to talk now about another way to do flow control, and that's exceptions. So first, a reminder of what flow control is. Flow control is everything that affects the sequence of operations that you will perform, the sequence of statements that will be executed. So it will affect the flow of the program, basically. We've seen a few examples so far. We've seen the loops, for instance, the for loops, the conditionals, if and else, things like that. You can define new functions, which basically gathers together a few statements that will be executed all at once, and then you jump back to another part of the execution. And we've seen generators and iterators that generate a lot of objects and allow to construct some kind of loops. We also have seen operator switching. So this is expressions like A or B, where B is only evaluated if A is not true, does not cast to the Boolean true. Okay, so this is also a form of flow control. Now, the important one I want to emphasize, because it will be very relevant for exceptions, is the functions. So how did functions work? Well, we define a function and it has some arguments that were allowed for that function, and then a bunch of statements, and at the end maybe an optional return statement, return another object. So the way this worked is that this was called from somewhere else in the code. So somewhere in the code you would have function called with some values here, and this execution would jump here. Now, the point I want to insist is that you remained within the function for as long as you hadn't touched return, and once return was touched, then everything else was discarded, and only the argument of the return, if you want, so the object here, was returned and passed back there. Now, for exceptions, things will be slightly different. So for exceptions, you can throw and catch exceptions. That's the two important words here. So throwing and catching. And the way it will work is that you define some blocks. So you will define some blocks that are being watched by some other block. So if you want, you have some block of code here that is under the watch of this block of code there. Okay? And this block of code over here is meant to catch an exception if the exception is thrown within this block. And if the exception is thrown within this block, then you don't get all the way to the end, or you don't execute a return or anything. An exception is thrown, and suddenly the whole flow that was supposed to happen here is completely forgotten. The exception is thrown, and then we're looking back whether there was another body that was supposed to catch exceptions occurring within this one. All right, so this body here, the one below, watches the one above. And whenever an exception is thrown here, we're trying to see if this body is actually meant to catch the exception that occurred within this one. And if it is, then we execute statements within this body. So for instance, imagine you're trying to open a file over here, but the file does not exist. Well, you will throw an exception saying that the file does not exist, and this exception will be caught by this part that will say, please create the file first, or something like this. But in normal operation, no exception is thrown, so this code always executes. And then this part has no reason to be executed because no exception is thrown, so you just jump and go on to the remainder of the code. Okay, so this is a simple exception with just one block throwing exceptions that are caught right after. But you could have one big block here that actually calls a function here that is defined somewhere else. Okay, and like before, this whole thing had a bunch of statements, and then in normal operation, you go all the way to the return some other statement. So in normal operation, you do all those, then you execute function, you return something, you go on, and then you jump here. That's the normal operation. But sometimes there might be an exception here that is thrown. For instance, you have some calculation to perform. First, you open the file and you read in the file. But here, when you open the file, actually an exception is thrown. So here we will throw an exception. And the point that I want to emphasize now with this idea with the function is that no block is right below here watching the exception. Okay, so the exception is thrown, and then immediately we'll look, okay, so how are we supposed to catch this exception? Well, no block exists there, so we're not supposed to catch the exception within this function. So let's go back up. Let's alert here that an exception is thrown. Is there a block watching this part of the code? Oh, yes, there is. Does it match the exception that is actually thrown? Because there are different types. And if yes, we do something. If not, we jump back up again because this exception is thrown here but hasn't been caught. So we go back one layer, and we go up, and potentially we go up all the way back to the interpreter. And this explains a lot of the tracebacks that you have been receiving when programming. You've been receiving exceptions that were basically not caught at any point. And as it was going back up different layers, it was also collecting in which function it was actually occurring. So if you want, the traceback of this exception here, if it's never caught, would be first the function, and then this part, let's call it function 2, because it's not caught here. So let's say function 2, and then it's thrown back, and so on. So the traceback will collect function 1, function 2, and will tell you at the end, well, this is the exception I had, but it was never caught. Okay, so this is the abstract description of exceptions, but how does it actually work in practice in Python? So in Python, you might have some code here, so what I called some code 1, and then some code to do at the end, so some code 5. And then the important thing is that you have a try block, and here I put 2 except blocks. So in the diagrams that I was drawing in the previous slides, those 2 blocks are watching this block here. Okay, so if everything is peachy and everything happens fine in some code 2, then what actually happens is some code 1 is executed, then some code 2, then those things are never executed, and you jump right away to some code 5. Okay, so that's normal operation. But then at some point, some exception might be thrown in some code 2. And the way you throw an exception is with raise. So we'll see this in the examples, but raise throws an exception. So once this exception is raised, then we're looking for a matching block, a block that will tell us how to catch the exception. And there are different options, so different types of errors. So we'll say except, well, if it's an error of this type, and we assign it this value, then do this and that. And do this and that based on exception value and on the type. So you can do different things like print on the screen, please enter an integer and not a string, or things like that. Or you can decide to rethrow an exception, again using raise, but a slightly different one, or do different things like this. It completely alters the expected flow control when everything goes fine. So when everything goes fine, it's 1, 2, 5. But if there is a problem that is caught by this block, then it's going to be 1, parts of 2, 3, 5. Okay, and it's going to be 1, parts of 2, and then code 3, and then who knows? Maybe we'll throw it again and go back up, or maybe we're just happy with having caught the exception and we can go on, and then we do code 5. All right, I said here that several code blocks were watching this body here, and indeed, it could be that the exception thrown does not match some exception error, but actually matches some other exception error. And then instead, we'll do some code 4. So you can see how there is some flow control here that will be altered, because you enter here and you don't know whether you'll do 1, 2, 5, or 1, 2, or parts of 2, 3, 5, or 1, 2, or parts of 2, 3, and then go back, or whatever, or 1, 2, 4, 5, 1, 2, 4. There's lots of options. Okay, so some exception error is here, some exception, all right, but I didn't make it precise which one. So there are different options that are built in. So those are built-ins, and by inheritance, you can define your own based on those. So it could be index error, it could be key error, it could be IO error, or type error, things like that. So index error and key error typically occur when you try to access something that does not exist. So the 5th entry of a list of length 2, or a key that's not in a dictionary, something like that. IO error occurs when you're trying to open a file that does not exist. And type error would occur when you're trying to do sums or operations on objects that don't support it. There's a lot of different exceptions that are built in that you can use, and in the documentation you will see links to those. So finally, I should say, and this is quite important, that Python encourages you to use exceptions. Unlike other languages where exceptions come with a penalty, the penalty for using exceptions in Python is very low. It's the belief of the designer of the language, Guido van Rossum, that it's much better to write the code as it's supposed to be executed most of the time. So 1, 2, 5, and if you want hiding away this and that towards the bottom, which are the things that are never supposed to occur or rarely supposed to occur, or actually not in the most general case. Okay, so the most general case should be still straightforward, 1, 2, 5, but you're allowed to use the exceptions quite liberally to do different things. And the point is to put them afterwards, so you don't have to put checks beforehand. If the file exists, do that. If the file does not exist, do that. Instead, you just try to access the file, and if the file does not exist, then you do something. So it's trying to encourage you to use exceptions. Just trust that the program will work, and actually implement later, further down in the code, the rough cases where not everything works according to plan.